Hello everyone, this is Mayuk Mazumdar and I'm back with another exciting session. So let's proceed. So in this session, I'll be giving you an informal introduction to our Python interpreter. Before we begin, let's narrow down what we mean by a Python interpreter. The word interpreter can be used in a variety of different ways when discussing Python. Sometimes interpreter refers to the Python REPL, that is the interactive prompt you get by typing Python at the command line. Sometimes people use the Python interpreter more or less interchangeably with Python to talk about executing Python code from start to finish. In this session, interpreter has a narrow meaning. It's the last step in the process of executing a Python program. Before the interpreter takes over, Python performs three other steps: lexing, parsing, and compiling. I hope you all are aware of these terms. So, together these steps transform the programmer's source code from lines of text into a structured code objects containing instruction that the interpreter can understand. The interpreter's job is to take these code objects and follow the instructions, and hence give us the required output. You may be surprised to hear that compiling is a step in executing Python code at all. Python is often known as interpreted language like Ruby or Perl, as opposed to a compiled language like C or Rust, as we all know. However, this terminology isn't as precise as it may seem. Most interpreted languages, including Python, do involve a compilation step. The reason Python is called interpreted is that compilation step does relatively less work, and the interpreter does relatively more work than in a compiled language. So let me begin with introducing you to the Python command line. So I'll be going to my terminal, and if I simply write as the Python keyword, so over here I am introduced to the Python command line. So I would just like to welcome you all by saying print statement. So within the parenthesis and within quotes, I've written hello world, hello everyone, and I've put this under this print command. So on entering, say, the Python terminal command line gives me the output as hello everyone. So I'll be simply using Python as a calculator. So for that, let me introduce you to numbers. The interpreter acts as a simple calculator. You can type an expression at it and it will write the value. Expression syntax is straightforward. The operators plus, minus, star, and division works just like in most other language. So if I add 2 plus 2, the answer is 4, and Python interpreter gives you. So if I do another operation like 50 minus 5 into 6, it gives me 20. That is 50 minus 5 6 is 30, that's 20. So now I would if I want to perform some division operation, so 50 minus 5 into 6, and if I divide it by 10, so it should give me 2.0. Yeah, that's my answer. So now let me perform a division as 9 by 5. So it gives me 1.8. So division always returns a floating point number. To do float division and get an integer result, so we can use this operator. So using this double slash operator instead of a single slash, it gives us the float division. So also to perform other operations like this classic division, if I divide 17 by 3, as I said, that floating point answers will be given. But similarly, if I use double slash operators, so this will give me a integer result. Now, if you want to know the remainder after division, so when 7 is divided by 3, 17 is divided by 3, what's the remainder? If you want to know, then you can use this percent by modulo symbol. So on using this, say 3 5 is the 15 and the remainder is 2, so it gives, the Python interpreter gives you this 2 remainder as the result. So instead of searching for calculators in your mobile phones or in laptop, you can simply use the Python interpreter. It's your easy hand interpreter calculator. Now, if you want to perform some stronger expressions, some expressions as which includes more than one operation, so that also can be done in Python. So I'm gonna multiply 5 with 3 and then add 10 to it. So if I do, the answer is over here. Now let me introduce you to Python variables. The equal sign is used to assign a value to a variable. So when I declare a variable name, maybe width of a rectangle as 20, then this variable with, sorry, I made a spelling mistake. So this variable with underscore rectangle is assigned to a value of 20. Now if I wanna assign the height variable to some values, or maybe the length variable to some values, as 30 maybe, so this length rectangle, that this variable is also assigned to a value of 30. Now if I want to find out the area, then I can simply say as area equal to width rectangle multiplied by length rectangle. So when I do so, the variable area is assigned to the value of the area, and on simply stating, typing the variable name and on clicking enter, I get its assigned value. I can also do this operation by multiplying directly in the interpreter. See, you get the same result. So you can either assign the value to a variable, or you can simply print into the interpreter. So if a variable is not defined and then you try to use it, then you can give an error. Suppose this height variable, it is not assigned to any one, or maybe volume variable. See, I have not assigned it to anywhere. Now if I click on the volume variable name and click on enter, I will get the simple error, that is the name volume is not defined. So when we try to access an undefined variable, we will be getting an error, that is name error, name volume is not defined, or name variable name is not defined. So I can also perform operations with strings in my interpreter. For that, let me define string name is equal to maybe pi. So as for numbers, it goes over here same as well. So whenever I have assigned the value to a variable, that variable is allocated to that value. So over here string name is assigned with the value pi. Now if I want to make it a Python, means the string to be appended to thon to make it a complete Python, so I can simply use string name is equal to string name plus within quotes thon. So what it gives me, so if I now print the value of string name, see, you get Python. So pi was my initial value assignment, and then when I've added thon to the existing assignment over here, so on printing I get as Python. I can also directly do so. So if I have assigned string name as pi and then I print string name plus within quotes thon, so over here say the output is Python. Strings can also be indexed, that is subscripted, with the first character having index 0. There is no separate character type, that is a character is simply a string of size 1. As you can see in Java, that char variable is char data type is used to assign or allocate values of type character, but in string you don't get as such. So maybe string name is equal to string name plus thon. Then if I print string name, so it's now Python. So string name of 0 will return me with variable p because it has been indexed and the indexing starts from 0. So for Python, the first P stands for index 0, Y stands for index 1, T stands for index 2, H stands for index 3, O stands for index 4, and N stands for index 5. So you can simply check index of any one. Suppose at a fourth index you want to check the value, so it's O. So it's quite simple and easy to use these characters as because there is not means it's simply a string of size 0 over here, a character variable. So now you wanna, in addition to indexing, slicing is also supported in Python. While indexing is used to obtain individual characters, slicing allows you to obtain strings. What's that? Suppose I have assigned the variable word equal to the average student. So this word is allocated to the value the average student. Now over here let me just remove the space for better understanding. So when I have done this, so let me print what. So over here T stands at index 0. Okay, as I've said, the indexing of a string starts from 0. So our 0th index element is T. Let me show it to you. So T of 0, the word of 0, it will return me T. Now I want to extract the first 3 words. So what do I do is, over here, similarly to indexing, now here I'll be slicing. So let me slice the first 3 words. So what it will return is, it will return me the elements of index 0, 1 and 2. So when I do so, boom, I have the. So how does it come? It comes from the slicing, that operation that I have just now performed for index starting from 0 to index starting to 3. That means the elements of index 0, 1 and 2 will be returned to me. Now if I want to extract the slice the elements that are not starting from 0, that can also be done. Suppose I want to extract all the elements from index 3 to index 10. So if I do so, see, at index 3 we have the space because 0 is T, 1 is H, E is 2, then the space is at index 3. So for better, let me slice from index 4 to 11. Then you get this average, the term average, which lies at index starting from 4 to 10. So that's the slicing operation in Python. Now let me introduce you to lists. Let me define a list as squares and assign values to it as 1 or 4, 3 square is 9, 4 square is 16, 5 square is 25. So that's my list of squares of elements. The elements itself are the squares of number 1, 2, 3, 4 and 5. Like strings, all the other built-in sequence types list can also be indexed and sliced. So now if I want to find out the element that lies in the first index, the 0th index, so it's 1. So at 3rd index the element is 16. because that 0th index, the first element, the element is 1. At first index, the element is 4. When index is 2, the element is 9. And when index is 3, the element is 14, 16. And when index is 4, the element is 25, as I said. So if you want to, just let me show you some magic. That if you want to, you don't know the length of a list, but you want to know the last element of a list. So it can be simply done by indexing, keeping the index field as -1. So when you don't know the length of a list, so you can simply, to extract the last element, simply give -1 as the index position, and it will return you the element that lies in the last of the list. Now you want to slice the list. So for that, you want to extract the first 3 elements. So the elements of index 0, 1 and 2 will be returned to you, and boom, it's here. The elements of index 0, 1 and 2 are here. Now maybe you want to extract the last 3 elements of a list, but you don't know the length of a list. That can also be done. It's quite simple. Since it's the last 3 elements, so it's just simple. Index, place the index as -3. Sorry, you have to place a colon as well. So that's it. So over here you will get the elements of the last 3 indexes. Now all slice operations, as you can see, will return a new list containing the requested elements. This means that the following slice returns a shallow copy of the list. So when you just simply want to extract the entire list, you can do so by simply printing this, or you want to slice all the elements of a list, so you can simply do so by this. Anything, it gives you quite a range of options that you have in hand. You can also as well concatenate elements to a list. So for that, that's a quite simple operation. Now let me concatenate elements to square. So see, I have this squares variable. Now I will be adding more elements to it. 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, and 10 square is 100. Is it 100? Yeah, I'm right. So if I add, then see, you get all the elements to be concatenated to it. Now one more thing that I want to show you is how to check the type of a variable. You don't know, you just have a variable name, but you don't know what's that. So you can simply check it in Python by using this type command. So type of squares will return you, see, it's a type of class list. Another thing, everything in Python is considered as an object. So even this class list is an object whose type is list. So suppose I have assigned world equal to the average student. Okay, now I'll be finding the type of word. See, it's a class string, but it's an object. So this word is an object of type string. So in Python, everything is considered as an object. Now, one magic you want to see. Okay, let me show you. So in squares, sorry, my mistake. So in squares, we have the elements this. Now over you got to see that when I've concatenated, it has printed all the elements, but I have not assigned it to a variable. Now as long as I don't assign, the value of the variable remains unchanged. So what will I be doing is I will be assigning values to this variable. Now see, now I have assigned. Now when I print squares, so it gives me the entire complete list after concatenation. But as a matter of fact, this is not a simple printing statement by just simply typing the variable name when you will be coding. Since it's a Python interpreter, so I'm interacting it with one-to-one, so that's why it's showing the result. But when I code down, on simply typing the variable doesn't give us. For that, we'll be using the we have to use the print statement. So then you get to see. Now what I was saying about the magic is that, say all these numbers you can get to see. Now let me print, let me just show you the squares of 0. If we index, means if we want to find out the element in the 0th index is 1, or maybe for better, let me show you the 5th element. Okay, any element I can, just I wanted to show you something other than 1. So over here you got 36 as the number. As you can see, it's a integer, but when I print the type of this, and that's the magic that I was saying about. When you say, so type of a object of list is an int, as you have said, but when you say var equal to 5 and you want to print the type of var, so similarly you get, when you assign a variable as when you assign an integer variable to an integer element to a variable, you get the type as int. And when you assign variables to an object of type list, and if the element is int, so in that case, when you find out the type of a specific element which is of type int, you will get the type of type as int. But when you find out the type of the entire object, you will get it as a list. So till now I've introduced you to numbers, the strings, the list, and then what I can do is I can do various multiple operations on it. So now let me change the value of a particular element in a list. So suppose someday I find out that the square of 3 is not 9. Suppose that's not gonna happen any day soon or ever, but suppose I'm saying that the square of 3 is not 9 and I have to make changes to this element, to this list. So what I do is simply, 9 is at the index 2, 0, 1, 2. 9 is an element, or 9 is sitting at the index 2. So I just have to modify it and say, suppose the square of 3 someday becomes to 999. So when I do so, and then I print squares, so see the value, the list is modified at the index 2, but I was wrong quite undoubtedly. That's why I will be reassigning the actual value to the squares list, and when I print it, you see the element has been again changed. So we can replace the value of a list at any specific index. Also, we can add new items at the end of a list by using the append method, and about it I'll be showing you more in coming sessions. So the built-in function len also applies to list. What happens is, I don't know the length of a list, but I have to iterate over each element. I can do in various ways, but my standard programming approach, what says me is to iterate over each element of the list for the entire length of the list. Now for that I do need to know the length of the list, but I don't know. So what I can do, I can simply use this len keyword and give the list name within parentheses, and when I do so, I find the length of the list is 10. Over here, how many elements are there? Let us check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, so 10 elements are there, and as a result, the length of the length of the list is 10. But its index ranges from 0 to 9, whereas its length ranges to 10. Okay. It can also be done for suppose for a string element containing strings, for a list containing strings. So if I do so, I simply define them within quotations to define that they are of types int. So if I do so, and then I try to check the length of the string named as letter, when I do so, it gives me 3. So for any list, if we are simply using the length keyword, we can find out the length of the list. Now we can perform various operations. Now see, I have two lists, one is squares and one is letter. So let me frame a new magical list, and what magical list will contain is elements of both the list. Okay, so let me first include the elements of squares to it. Now if I print this simply means if I check this magical list, see, it has all the elements of the list squares. Now what I want to do is I want to frame a new list. Let me sorry, I made a mistake. So I just wanted to show you how the elements of one list can be appended, can be included into another list as well. Now let me frame a new list which will have the elements of both the list. So magical list new is my new list which will have the element of squares list, squares list as well as letters list. Okay, so on defining in this manner, what I'll get is that, let me show you. When I try to print it, so I get a list which has its elements as a list itself. So what it becomes, it's a list of lists, ain't it? There are two lists and these both together are combined within a single list. So this a list, this a list of list. So if I print the length of list, what you get is that there are two elements, so it's 2. Now what should be the element of index 0 in this scenario? Should it be 1? Should it be the entire list? Let's check out. So when I find out the elements of the 0th index for this new list of lists, you will find that it's the entire list. Now if I want to iterate to this element 9, so what should I use? Then I should use the element of the index 2 of the 0th element of the list of list. See, I get the output as 9. So this was all about handling operations in the Python interpreter when you have small tasks. So in that scenarios, you can simply use the Python interpreter to test a short amount of code in the quickest and the easiest, not to write in the code in a file. This is made possible because Python can be run as a command line itself. So when you are done with all your operation, you can simply type the following to quit the Python command line interface. And what you have to type, it's exit. Bye bye. Ta-da. When you click on exit, boom, you're out of the Python interpreter. And as a matter of fact, when you access again the Python interpreter, so if you try to find out the element, the magical list new that I've just defined, sorry, it's not there. When you are done, when you exit from the interpreter, you get elements, all the operations that you have done are out of the memory. So that was all about today's lesson.